Gerhard Rill here, orthopedic shoemaker and orthopedic technician and German podiatrist and certified pedorthist here. I'd like to talk to you a little bit about the offerings that Reba has for some of their new products that we'll be introducing in some of our video clips today. A little background on my persona, which is started my education in this field in 1977 with some preemption from my dad, who's been in this business since 1947, and a little bit of gathering of information both in Europe and here. Have been active in both teaching and technical consulting in the world of orthotics and footwear for the last 4 decades. The product line that we'll be introducing today will be a combination of functional foot orthoses as well as an AFO product. Just to show you what's out there, we've got various, which you've probably all seen, various materials, various methodologies, and various constructs. Anyways, so we're back again with the Reba Ultimates with a deep heel cup called the Ultimate Anatomic, and then the Reba Standard, which has a flat heel cup. They're both made out of the identical materials, slightly shaped differently, and slightly different applications. They're bondable with all your typical top cover materials, whether it's EVAs, whether it's leather, whether it's felt, whether it's urethanes, and it's bondable with all the typical adhesives that you would see in the industry. So there's no special prep necessary, there's no primer necessary. Basically, apply your adhesive, follow the instructions of the adhesive, and bond your materials. The substrates of many of your materials, of your orthotics out there, probably anything from polyethylene to polyurethane to some of the classic graphite configurations, along with the classic cork leathers that you see. And they're not bad devices. They have their advantages, but they also have their limitations. And that's not to dismiss the validity of any of the devices out here, but we'd like to show you why the Reba Ultimates are a pretty good comparison, and in some cases you may find them easier to work with, a little less challenging from a construction and cementation standpoint. So back now with some of the material and dimensional comparisons. We'll get into the technical stuff here in just a little bit, but if you're looking, for example, a standard lady size 8-9, we're looking at about a thickness with the Ultimate of about 2.5 millimeters in the forefoot, in the arch about 3 millimeters, and then with the flat heel cup, we're looking at 1.5 millimeters. There are devices out there that are comparable in thickness, but unfortunately, their stability is lacking, so we'll set that one aside. There are other materials, again, similar and comparable thickness, but I'm not going to snap it all the way because it makes a big noise, but we'll get to the snapping demonstrations later. So I'm going to set that one aside. There is another product out here, similar in thickness, great configuration. Unfortunately, it's a Duroplast. It can be heated all day long, and it'll never change shape because it's not thermomoldable. We'll move on to some of the classic materials, such as your polypropylenes. Great shape, great contour, but about twice the thickness. So we'll move those aside. So we'll move to some of the classic carbon fibers that you've seen. Looks great on bicycle frames, automotive components, motorcycle components, but unfortunately, it's structurally sound. It looks really cool, but when you put it under excessive load, which we will be doing. Normally, these are loads you probably wouldn't put these devices, expose these devices to, but we're going to move over here. We're going to put it to a test that I don't recommend at home. If you do, wear your safety glasses, and all right, and that's one of the reasons why we don't use that material. So we're going to take the Ultimate, and we're going to put it to the same test, okay? And that kind of answers itself. So, and we tried that before and used the same material, and it performed just as well. So basically, when you look at the ultimate anatomic and the ultimate standards, you'll see that the material composition that we use gives you the opportunity to bond it with all your standard materials, with all your standard adhesives. It is thermomoldable, so you can heat it, reshape it, not just once, not just twice, but as often as you need to. We're going to also go into the lab and show you the difference between one of the composite materials in the oven and in the molding process, just to give you an idea of how it performs and what its stability is. Also, there are no special storage requirements for this material. You can store it in the freezer if you'd like to. I don't suggest storing it next to your favorite beverage, but you could, and you could then take it into the lab and work with it at the moisture and temperature that you've just taken it from your favorite place of storage. Many of the other composites require special handling when it comes to both storage and prefabrication preparation. Like I say, this one, you take it out, pick your size and put it to work. If you're going to use it as a semi-custom application where you would just apply a top cover, or there may be instances where you use the shell just as it is, and you know, there are many over-the-counter devices that you've probably seen in various environments, whether it's retail or in clinical, and one of the things that you see here, for example, the base material of this device, you know, it kind of performs as expected, and it leaves a structural weak point behind. And as you start seeing this, you can see what's called a white fracture line, and that's after 2 or 3 flexes. Now you take the same base material, which is the ultimate material, and you know, we haven't counted how many thousands of reps it takes to finally fatigue it, but it's got a few zeros behind it. Anyway, so you could actually utilize this in a semi-custom environment as well. As far as temperatures and heating goes, for those of you that are already asking that question, we'll address that when we go into the lab, and we'll show you some comparisons to, you know, material heating and shaping characteristics. But in the meantime, thanks for viewing our videos, and if you have any questions, you know, give us a call on our toll-free line.